class, so we're just going to go over lesson 6B exponent rules together. So we found out in our last investigation that we had a bit of exponent laws. So the first one was a multiplication law, then we had our division law and our power law. So I'm just going to go over a few of these with you. Before we get started, let's just do a really quick review from our investigation. So this entire thing within this bracket, that means that this A and N included is what we call a term. A term, a number, anything like that, but I'm going to use the term. And then this orange one right here, this is going to called the exponent or the power, whichever one. We use those words interchangeably. And then in this situation, this A right here is what we call the base, and sometimes I will refer to that as the number, right? But the correct term for it is the base. Okay, so if we have here our multiplication law states that for a number or a base that have the same, for numbers or bases that are the same, when you multiply those two together, you add the exponents together, right? So an example of that is if you have 5 to the power of m multiplied by 5 to the power of n, right? It would be m plus n. So say I had 5 to the power of 2 times 5 to the power of 6. I would do 5, 2 plus 6, 5 to the power of 8. Right? So that's the general rule of thumb there. Okay, and I'm just going to go in and draw a line. Actually, I'm going to erase that. I'm going to draw a better line than that. Right? And so I'm just going to draw a nice squiggly line so that we can separate them. And then, so for division law here, we have that when you're dividing, right, so that's why it's called a division law. When you're dividing for a number of bases that are the same, when you divide, you subtract the numerator exponent from the denominator exponent. So we do exponents of the numerator minus the exponents of the denominator. So in this case, it would look like 5m, numerator exponent, denominator exponent, minus n. So say if I had 5 to the power of 8 over 5 to the power of say 7, right? No, let's not do 7, let's do 6, right? I would do 5, 8 minus 6, which would give me 5, because the numerator minus denominator, 5 to the power of 2. You can also have something like 5 to the power of 6 over 5 to the power of 8. And you would do 5, 6 minus 8, and because you're still doing the top minus the bottom, you're not going to go the other way around. And if you had 5, 6 minus 8, you would have just negative 2, right? So you would write it as 5 to the power of negative 2 or as 1 over 5 squared. Okay, don't worry about that too much right now. When we get to unit 3, we'll actually cover that. Or unit 2, sorry. Okay. So power law states for numbers or bases that are the same, when you have a power to the power, you would just multiply the two powers together. So in this situation, so power law indicates that when you have a power to the power, you multiply the two powers together. So in this situation, you would take 2n multiplied by m. So an example of that could be, say you had 2 to the power of 6, to the power of 6, all to the power of 3. You would do 2, 6 times 3. 2, 6 times 3 is 18, so it would be 2 to the power of 18. Okay, so that's just a review of our exponent laws that we had covered in our investigation 6B. So we're just going to move forward now. And we're just going to be working with these numbers, right? So we just want to do some practice questions with them. I would suggest trying to do these by yourself first, knowing what you know from the previous exponent rules worksheet that we had done, right? And then we can just take them up together. So try doing these by yourself and then just come back and watch how I take them up, because that's the most important part of this lesson. It's more practice than it is for us to be learning anything new. So if we have 4 to the power of 3 multiplied by 4 to the power of 9, right? We have 4 and 3, and we're multiplying. So let's just go back and look at our multiplication rule. So when you're multiplying and you have the same base, you add the exponents together. So I'm going to go back here and say, all right, 4, 3 plus 9, right? And I'm just writing them as a single power, which means I'm not evaluating. Do not evaluate. You just need to write it as a single power. Evaluating will take you way too much time. So I'm going to do 4, 3 plus 9 is 12. So I know it's 4 to the power of 12. And I'm just going to leave it like that. I'm not going to bother doing that. Here I have 5 to the power of 19 over 5 to the power of 8. I always like to write these as overs, right? And then I'm just going to do 5, 19 minus 8, because when I'm dividing, I'm subtracting the numerator from the denominator. 19 minus 8 is 5 to the power of 11. Now I have a power to a power, so if I go back and look at my power to a power rule, it says that I'm going to multiply the powers together, right? So I'm going to do 7, 5 times 3, 7, 5 times 3 is 15. So how I usually go about these is I actually print out this page for myself, like the first page, and I just like to keep it on me until I've memorized the power rules. Right, so now I have power to a power. You need to remember BEDMAS. You always need to do your exponent first, right? So I'm just going to write that in, BEDMAS, and then you multiply. So let's do our brackets. We have nothing in our brackets, so we can leave that. Let's do our exponent. So we have 3. It's a power to a power, so we're going to multiply the two powers together, and that's all going to be multiplied by 3 to the power of 10. So let's just do that. 3, 6 times 2 is going to be 12, multiplied by 3 to the power of 10. And when I'm multiplying, I know that the rule is add them together. Right, so 12 plus 10 is going to give me 22. So it's 3 to the power of 22. I'm leaving it as a single power. Now we're going to go here. We're going to do 12 to the power of 15 divided by 12. Same thing as writing 12 to the power of 15 divided by 12 to the power of 1, because it's just to the power of 1, right? And then I'm just going to do it, right? So I know when I'm doing my division rule, it's top minus the bottom. So 12 minus to the power of 15 minus 1 is 12 to the power of 14. Okay? Then next one I'm going to do is 4 to the power of 24 all over 4, 3 to the power of 7. And again, we're just going to follow BEDMAS here. So brackets, we have none. Let's do exponents, right? So our exponent here is going to be 4 to the power of 24. We'll leave that alone, right? Because we don't have an exponent there. But at the bottom we do. So a power to a power is just multiply the two powers together. So we have 4 to the power of 24. 3 times 7 is 4 to the power of 21, right? Then I know that when I have division, I can just take the power of the top, the exponent of the top, minus the exponent of the bottom. 24 minus 21 is going to give me 3. So I have 4 to the power of 3, and I'm just going to leave it as is. I'm not going to solve it. Okay? And I'm just going to put this somewhere that's still in the same, so that it's not impeding with my second one down there. Now I'm going to move on. We're going to do this over here. So again, following BEDMAS, we got to do the exponents first, then we can deal with the division and the multiplication. So let's do the exponents first. We have 8 to the power of 3 to the power of 5. When we have something that's a power to power, we can just multiply the powers together. Right, so we're going to do 8, 3 times 5, all over 8 squared to the power of 3, 8, 2 times 3, right? I have 8 to the power of 15, 8 to the power of 6, and now I have a division, which I know is going to be 8 power of the numerator minus the power of the denominator is going to give me 8 to the power of 9. Okay. Now, this is where it gets a little bit more complicated, but really you just need to remember that these are always in brackets, right? So when you have a fraction, the numerator is in its own bracket, the denominator is in its own bracket. So let's deal with the numerator first, right? Numerator is going to be 6 to the power of 8 times 6 to the power of 16, which we can just say is 8 plus 16, right? And then the denominator is going to be 6 to the power of 3 times 6 to the power of 4, which we know we can just add those two together. So we have 8 plus 16 is going to give us 6 to the power of 24 all over 6 to the power of 7, because 3 plus 4, right? And now, since it's division, right, we know we can take the power of the numerator minus the power of the denominator. So 24 minus 7 equals 6 to the power of 17. And that's it. That's the answer. Right? So it's just really easy if you take it step by step to go through these. This one is way more complicated. We got division, we got multiplication, we got double division. So let's deal with this step by step. Let's deal with the numerator first, because we know that the numerator is its own fraction, right? Or is its own bracket. So let's deal with the numerator, and then we'll go on and deal with the denominator after. Just remember you have a denominator, so you need to deal with it. Okay, so the numerator is going to be 10 squared times to the power of 3 times 10 to the power of 10 all over 10. Right? So let's do this first. Let's do the let's do the exponents first. So let's do the exponents. We have 2 to the power of 3 over here. So let's deal with that first. Let's do 10 times 2 times 3. 10 to the power of 2 times 3 times 10 over 10 divided by 10. And then that 10 is also just to the power of 1, right? So if it's easier for you to write it in, go for it. So then I have 10, 2 times 3 is 6, multiplied by 10 to the power of 10, all over 10 to the power of 1, right? So now I know when I'm multiplying fractions, I'm going to do 10, 6 plus 10, all over 10 to the power of 1, right? And then I know it's going to be 10. 6 plus 10 is just 16 over 10 to the power of 1, right? And when you're when you're dividing fractions, you're just going to subtract those two from each other. So you're going to do 16 minus 1. So I'm left with 10 to the power of 16 minus 1 is equal to 10 to the power of 15. Right, so far, so good. I finished my numerator. I'm going to shift my focus to the denominator, so I know I have 10, and that one's easy. So I'm just going to go in and write it at the bottom here. Denominator, this one I probably should have given myself more space for, but that's okay. It is 10 to the power of 3 to the power of 3, right? Which I know is just 10 to the power is, you multiply those two together, 10 to the power of 9. So what I can do is now, I know my numerator is 10 to the power of 15, and I know my denominator is 10 to the power of 9, so I can just do that math. So 10, 15 minus 9, right? 10, 15 minus 9 is going to give me 6. So I know that my answer is 10 to the power of 6. Okay. And that's my answer. So just make sure if you're going to do it this way, you separate the numerator and the denominators, and then you just remember to add them together after at the end. Because I think that seems to be the mistake everyone makes. You are more than welcome to solve these if you want all in one go. Like, I'm completely okay with that. I'm just breaking it down for you. Okay. So this is where this gets complicated. Now we're looking at these two and you're like, missing, I can't do anything there. They're not the same base. They're not the same base, but can we make them the same base? Right? So if we go back and we think of, remember when we were talking about making them all the same bases? Can I make 4 and 8 a base that is similar to each other? I can break 4 down into 2 squared, right? I can also break 8 down into 2 times 2 times 2, which is 2 cubed, right? So I can write this all as base 2. And if I can write them all as base 2, I can now solve this problem, right? So let's go in and do that. So 4 cubed equals 2 squared, because 2 squared is 4, to the power of 3, right? So let's just go in and write that. So 4 squared equals 2 squared, which is 4, to the power of 3, and it's a power to a power, so we're going to do 2 times 3, 4 cubed, sorry, not squared, 4 cubed is the same thing as saying 2 to the power of 6, right? So we're done that. We've dealt with the 4 cubed. 4 cubed is 2 to the power of 6. So now let's go deal with our 8 squared. If we wanted to break down 8 and write it as 2 to the power of some number, let's just go into our calculator and say 2 times 2 is 4 times 2 is 3, right? So 2 to the power of 3 is 8, right? Now I want to do 8 squared. So 8 squared equals 2 to the power of 3 to the power of 2. So 8 squared is the same thing as saying 3 times 2 equals 2 to the power of 6. So we dealt with our 8 squared as well. Let's just go put that back into the original equation. So I can substitute now my 4 cubed as 2 to the power of 6 multiplied by my 8 cubed, which is 2 to the power of 6 as well, right? So now I have 2 to the power of 6 multiplied by 2 to the power of 6. They're the same base, so I can just add the two exponents together. So I can do 2, 6 plus 6 is equal to 2 to the power of 12. So when you're given different bases, right, and more often than not, when I give you different bases, what I'm basically going to be asking you is to simplify them into a base that is the same, something we can deal with, right? So try the same with 12. If you didn't get 11, pause this video now and go back and try 12, right? Because now you know how to do it. You just need to change 81 or 9 into a base that we can both work with. All right, so welcome back. 9, you can't really do anything about it. You can't really break it down more than it's already broken down. So I'm going to leave 9 cubed as the way it is. I'm just going to leave it. What I can change here is this 81. I can break that down into 81 is the same thing as saying 9 to the power of what? 9 times 9 gives me 81, so it's the same thing as saying 9 squared. So I'm going to go substitute and plug that in for the 81. So I'm going to just go here and I'm going to write 9 cubed to the power of 2 divided by 9 squared. And it's not to the power of anything, so I can just leave it as 9 squared in a bracket. Right? So then I'm going to go and just solve this. I'm going to say, okay, I have 9, 3 times to the 9 to the cube to the power of 2 is the same thing as saying 9 times to the power of 3 times 2, right? Because it's power to a power. And then 9 squared. So then I'm left with 9, 3 times 2 is 6 over 9 squared, right? And now I'm left with that division law, which just says you take the exponent of the numerator and minus the denominator. So 6 minus 2. So I'm left with 9 to the power of 4. And that is my answer. So when you're given something like this, you just need to make sure that you change one of the numbers into the same base. So here we changed to base 2 because you couldn't do 4 or 8, but here you could just change it to the 9, so it worked out. Okay? And that is it for lesson 6. And that's the end of unit 1.